The second integration technique that we're going to talk about is called the integration by parts. How this works is that if I can see my integral as the product of two things, I see two things being multiplied in my integral. If I can let one part be called u and the other part be dv, then the integral of u dv is going to be u times v minus the integral of v du. Now, the hard part of integration by part is usually in identifying which part I want to be u and which part I want to be dv. And if that works, this latter integral, the integral of v du, should be easy to find. For example, if I have my integrals here, this is the integral of log of absolute value of x times x dx. So I'm gonna let my u be the first half here, and let my dv be the latter half here. So my u is gonna be log of absolute value of x, and then my dv to be x dx. Now, if I choose u and v correctly, I should be able to take the derivative of u to find du, and I should be able to integrate the v here to find what v is. So once I pick what is u and what is dv, I have to find what is du and what is v as well. So du, I just need to take the derivative of this thing. The derivative of log of absolute value of x is going to be just 1 over x dx. And for v, well, because I knew that dv is x dx, so to find v, I just have to integrate this function. So the integral of x is just going to be x to the square. It's just going to be x squared over 2. Okay, so notice how if I take the derivative of this guy, derivative of x squared over 2 is just going to be x dx. So this is my v and this is my du. So from the integration by parts, I have the integral of u dv. So this has to equal to u times v minus the integral of v du. Let me now plug things in. My u is log of absolute value of x. So I have my u times my v. My v is just going to be x squared over 2. X squared over 2 minus the integral of v du. My v is x squared over 2 now. And then my du is just 1 over x dx. Let's see, my x cancel out here. So I'm just going to be left with log of absolute value of x times x squared over 2 minus the integral of x over 2 dx. Notice how now I can find the integral of x over 2 using just the usual formula. So I can find the integral of this thing. So that's just going to be log of absolute value of x times x squared over 2 minus the integral of x over 2 is just going to be x squared over 4, and then I add a constant. So this gives me the integral of this function here. So that's my answer for part A. Let's look at my part B now. I have x times e to the x dx. This looks like be two things being multiplied. So maybe I should let one part be u and one part be dv. In practice, however, to decide which part you want to be u, which part you want to be dv takes a little bit of trial and error. So for now, I'm just gonna let the first half be just u and the latter half be dv. So now I have my u is just gonna be x and my dv is gonna be e to the x dx. Now I just need to find what is du and what is v. Well, du is just gonna be the derivative of my u here. So the derivative of x is just gonna be dx. So my du is just dx, and my v, I need to find the integral of e to the x. I need to find the derivative of what function is gonna be e to the x, which turns out to be just e to the x. So now I can use the integration by part to find the integral of this guy. So that's going to be u times v, which is x times e to the x, minus the integral of v du. My v is going to be e to the x times du, which is just dx. And it just so happens that I can find the integral of e to the x. It's just going to be e to the x. So this thing will give me x times e to the x minus e to the x plus a constant. So here's my answer for part B.